Hi, everyone, and welcome to the module for AWS EC2 and EBS. And let's get started in this module. So in this series, we are going to talk about what exactly we mean by an instance, what we mean by EC2, how Amazon EC2 works. Then we'll be talking about the different type of instances available under EC2. So instance is a part of virtualization technology. So when you say virtualization, so let's say if you had a requirement of creating any server, so you can go ahead and deploy a physical server. Let's say you have a requirement for choosing Windows. So you can deploy a Windows-based machine, and then you can have all the applications installed and deployed, which needs a Windows OS at the runtime. So that's okay. But now if you have got a requirement that needs Ubuntu machine, Ubuntu image. So now we know that normally in a given server, we cannot run two operating systems at the same time. So what we can do, we can go ahead and deploy another machine, another physical server, and then we can configure Ubuntu image on top of it, and then deploy whatever application and data needs that. Same way, if you want to have, let's say, a Red Hat environment for cybersecurity penetration testing. So for that, we can create another machine because again, we will need a Red Hat environment to be up and running. So if we want them all to be running at the same time, then we have to have a different machine. So this is a typical case that we used to deal with almost 15 to 18 years back. Then the concept of virtualization was introduced where we can deploy multiple virtual machines on these physical servers, just like having a physical machine. So it can be useful for running multiple VMs at the same time where the resources of the physical server can be shared so that we don't have to stop one in order to create or run a new one. So depending upon the physical capacity of the main server, the others can be up and running at the same time. So instance is same like virtual machine. Instance is nothing more the name of the virtual machine given in AWS EC2 service. So all the virtual machines, we refer them as instance in EC2. EC2 has been one of the core services offered by AWS since its inception back on 2006. So EC2 refers to Elastic Compute Cloud. So here, in terms of virtualization, we can virtualize the servers, we can virtualize the storage, whatever we need to deploy any application. That is what EC2 is. And EC2 is based on pay-as-you-go model. That means we have to pay exactly for the number of hours that we have consumed, plus the capacity that we have deployed. So let's say if we are going to run an instance for 5 hours, we had to pay for 5 hours. If we keep them up and running for 500 hours, we had to pay for 500 hours and so on. That's how it works. And we have to pay based on the type of instance that we had deployed. If we had deployed an instance which has, let's say, around 2 cores of CPU and 4 GB of RAM, then we have to pay for that. If we deploy an instance where we are using a high performance, let's say 10 cores and 20 GB of RAM, then we have to pay for that and so on. So that's how the pricing of this service is defined, and it can be integrated into any other service. So almost all services, there are more than 200 plus services offered by AWS. So they all are going to be supported by EC2. And then we can ease in and scale down. So that means whenever we want to launch new instance, we can. Whenever we want to stop any of the existing instances that we have already deployed, we will be able to do that. We have that kind of flexibility available. So in terms of the work, we have to select the type of instance that you want to launch, then we can launch it, and then we can connect to the instance. So for the CLI based OS, we can make use of the SSH connection, and for Windows connections, we can make use of RDP. And then we can start using the instance to deploy and configure the application the way we need. So in order to see how that works, we will be looking at a hands-on module for EC2, so that we have a proper understanding on the functionalities of it. So that once we see how things work, we will be able to have a better clarity on how we can choose the right components while creating it and how things are going to be deployed in case we run into any kind of issues and what they could be. So let's go back to the AWS console so that we can get started working on our EC2 instance service. Now, this setup of the console is what we had seen earlier in our previous modules, where we had discussed on how these core services of AWS, they all are defined and how we can go ahead and make use of them. So now we are going to take this further. So this is the home console for the server. So we can see here we have this console, which we also refer as a GUI base of access. So here we can see what kind of users we have, what kind of resources that we have created. We can see what kind of services are up and running as a part of the homepage deployment. So we will be able to see all pieces of information available right in front of us. We will be able to see that. So now if we want, we can go ahead and get started working on a single service. Now, what we can do here is we can go ahead and make use of the search bar available on top. So that is the easiest way to navigate to any service in AWS. Even if we are in any dashboard in any of the services, it'll be easier for us to simply use the search bar on top and then get started. Right now, our focus is on EC2 service. So what we can do, we can simply type in EC2 in the top dashboard, let it reload. So we can search for EC2. So all the documentation services which are related to the keyword that we have searched for, they will be listed. We can click on EC2. Now in EC2, we have a global dashboard. When you say global dashboard, that means we have a region specific dashboard. That means right now we are in North Virginia because that is currently highlighted. That means whatever components we click on EC2, for example, if we look at the list of all instances or the instance type, the AMIs, volume, snapshots, load balancers, so they all are going to be listed, which may have been deployed in this region only. Suppose if we switch to some other region, then we will be able to see the list of all resources under these all parts in that region itself. That's why it is important to understand, to know that we will be able to see the list as per the region that we have currently selected. So let's say if you have deployed something in North Virginia and then you switch on to North California, then you will not be able to see the list of resources properly. So you may get confused, okay, where exactly the resources went. So you have to take care of the region selection. Next, we have the instances. So we can click on instance, which we refer as virtual machine that we had discussed already. So under the instance, we can see we have launch instance. So we will be able to see the list of all instances that we may have deployed, that may be running, that may have been stopped, or we can even see the list of all instances that we may have terminated. Because if we terminate any instance, then that is also going to be listed here for 1 hour after it gets terminated. So right now they are none because this is what we are going to start with. So in order to create any virtual machine in EC2 service, we can see we have the option as launch instance available on the top. So once you click on launch instance, we will be taken to this kind of screen where we can see the name. That means there are multiple entries that we have to do in order to deploy any machine. First thing first, it starts with name. Now, technically, if you want, we can name the machine anything we want, but there's nothing wrong with it. Technically, it is going to be deployed, but it is not going to be easy for us to find out what exactly this instance what is deployed for. If we have multiple teams who are going to make use of the same environment, then they will be also confused on what kind of resources are being deployed here. So for that, we have to ensure that we do process things in the best way possible. So you can give it a name. Let's say this instance is going to be a web server. So we can give it a name here as web server. Then we have any kind of application. For example, we are working for, let's say, a fintech company, or let's suppose a healthcare company. So we can add any kind of suffix or prefix so that in case we have multiple instances deployed, then we will be able to easily filter them out. Just by knowing the name, we can know, okay, this is what, this is the web server, and this is for which client, this is for the healthcare client, and so on. So this is what we can define. Now, here we are going to navigate to the next part, which is the application OS images. So just like every server needs to have an OS. Without OS, nothing can be executed. So same way, we have to know that again, without any kind of image, we cannot deploy any virtual machine. And we know that there are two main different types of virtual machine. We have two main type of virtual machine images. We have Linux-based images, and then we have Windows images. Within Linux, we have different distributions. Like we have Ubuntu, Debian, Fedora, Gentoo, open source, or we can also make use of different. Now within those variations, we have multiple sub-variations. Like for example, in Ubuntu, we have Ubuntu 20.4, 13.4, 16.4, 18.04. So you can choose accordingly. So here we can see the list of all, I guess, the most popular categories of AMIs. So we can click on browse more AMI to see the complete list. And we can see here we do have the AWS console, and we have the Linux 2 AMIs, then we have the Mac OS, we have these are the most popular AMIs available. If we navigate to the community AMI, we can see we have different divisions. Like we have Linux, CentOS, Debian, Gentoo, OpenSUSE, Red Hat. Suppose if we choose one category, let's say Ubuntu, then we have multiple variations of Ubuntu also made available here. So we can choose accordingly what exactly we need. So there's nothing like one image is better or worse than others. It's all based on the requirement. If we are going to create an application that needs Ubuntu 18.04, then nothing is going to be better than that specific version. And if we are going to deploy an application, suppose based on IS server, then we have to make sure that we do deploy it based on the Windows-based OS only. So it all depends upon the requirement. And apart from the quick start and community AMIs, we do have the section for marketplace AMIs. Now, under marketplace AMI, we can see there are multiple images available here. So these images are based on a base operating system, like we have Linux 2 or Ubuntu or Debian or Fedora. And apart from that, our application, whatever we need, will also be configured on top of it. For example, if you need to have Splunk use. Splunk is one of the most popular monitoring tool in DevOps. So we can either deploy an instance by using Ubuntu or Debian as a base image, as a base AMI. Then you can get connected to it, and then you can install Splunk with whatever environments we need. And so we can go with that, or we can go ahead and make use of this specific image. So some images, they are free, some images, they are paid. So for example, if you use this one for Sophos, so here we had to pay anywhere from $0.10 on a per hour basis or an upfront amount of $788. So this depends upon the application and the environment that is being configured here. So the application may not be free. It may be a licensed one. So that's why we have to take care of that. You have to even pay for it. If we are going to look for, let's say, one image, that is WordPress. Now, WordPress is the most popular CMS out there. So when you talk about WordPress, and WordPress is going to be a part of this image is offered in AMI section. So we can choose which one we want. And once you deploy this, so we don't have to worry about setting up the web server. We don't have to worry about setting up the PHP server, databases, and the WordPress installation. Everything is going to be automatically made available to us. We only have to think about configuring it. That's it. That's how it works in terms of these marketplace AMIs. Now, right now, as a part of our setup, we will be using, first of all, a Linux distribution, like we have Ubuntu, and then we will be looking at the next distribution, which is based on Windows. So we can choose Ubuntu, and then we can choose any specific version of Ubuntu that we need. Right now, we can keep it to latest version, which is 22.04. And here we are not getting the GUI. Here we are getting only the CLI access. That's it. So we don't need to have any kind of even RDP access enabled for this virtual machine. Then we have the instance type. So instance type is going to be based on our own requirement. So there are multiple instance types offered by EC2 depending upon whatever configuration we need. So we may have to look at different types. For example, we can see here, first of all, the first instance type is general purpose, where we have T2, T3, T4A, these kind of instance families are available here. So these are what we refer as general purpose. That means these are mostly like useful for use as jack of all trades. They are good for deploying small to medium scale applications, for SharePoint applications, for different, we can say testing or staging servers. So they can be all configured easily by using general purpose. And within general purpose, we do have multiple, we can say instance family that we have T3, T4, T4A. So they all may come with different type of instance type. For example, in T3, we may have the Intel processors. In T4, we have the AMD processors and so on. So these are going to be needed. So it's just like buying our own PC. So when we buy our own PC, there are multiple brands there for it. So we do have AMD processors, and then we have Intel processors. So it comes down to our own personal preference and choice, which one we want to go ahead with. So that depends upon the preference, and we can choose accordingly. And within those, we have different configurations. Like for example, in Intel, we have i3, i5, i7, i9, i11. So for example, if you are going to do some kind of basic browsing and simple basic office work, then i3 is going to be more than enough required. But if we are going to do some kind of heavy work in terms of creating machine learning models, then we have to go for i7 or i9. So same concept is applicable here. When we are choosing the instance type, we have to choose based on the configuration that we want. So that is what is given to us by these instance types. So here we have general purpose, which is like jack of all trades. We can go ahead and choose the environment we need, and it is going to deploy it accordingly. That's how it works. And to have some kind of computational heavy workloads deployed, we can make use of compute optimized instances. For example, when we are going to create any ad tech engine, we are going to create any kind of gaming servers, we are going to create some kind of dedicated servers as a mailing server. So there we need to have a good computation power needed. So in that case, we can go for compute optimized instances where we do get high-end processors. Then we have memory optimized instances, which are preferred for memory intensive tasks. For example, if we are going to create database engines, we are trying to run a big data analysis dashboard. So there we need to have good memory so that we can process large amounts of data, and that too as quickly as possible. So for these kind of requirements, we can go for memory optimized instances. And we can choose to change the instance type anytime we want. For example, we may have started with, let's say, compute optimized instances, and then after some time we feel that memory optimized is going to be better choice for us. Then we can always stop the instance and then we can change type. It's not mandatory that once you choose an instance type, that is going to be there. We can always choose to deploy something else. We have that kind of liberty. That's why the service is called as elastic. And then we also have the other type available, which is accelerated computing. And this is what we also refer as GPU optimized instances. That is graphical process unit optimized instances. So this is preferred for the GPU heavy workloads. For example, if you are going to do some kind of analysis on satellite imagery, where you need to process a good amount of video and images, you need to process a good amount of imagery data here. You are going to create a machine learning model which should work on the CCTV footage based on finding the object. So here, whenever we are going to process a good amount of video, that's where we are going to prefer using accelerated computing, which is in short referred as GPU optimized instances. And then we have storage optimized instances, which offers the least amount of latency, and that too for any application which relies heavily on the input-output operations happening on a per second basis. In simple terms, the number of read and write operations happening on a per second basis. And this is where we can prefer using when we are going to work with, let's say, some kind of Cassandra or MongoDB or Couchbase database systems, where these are like NoSQL, and we can prefer to have it deployed there so that we can get the best possible performance for having multiple parallel operations executed there. That's how it is going to be. So this is where we can prefer using the storage optimized instance family. Now, depending upon the requirement, we can choose. For example, if we are going to create high performance databases, there we can go for the memory optimized instances as a part of match the following. If you want to go for suitable data warehousing applications, so data warehousing is where we need a good amount of memory. So here we can go for the same, the storage optimized, and then we have the balancing of the computation, memory, and networking, which is like having jack of all trades, and that's where general purpose is going to be really helpful. And a high performance processor is what is going to be given by the compute optimized instances. So that is what we have to match for. So as we discussed, for high performance database, we have memory optimized. For data warehousing, we have storage optimized, where we can get a good amount of IOPS. Then for the networking computation power, we have the general purpose, and then offers high-end performance. So for that, we have the compute optimized instance family.